welcome to the chemistry class. So last class we discussed about the solubility of a solid in a liquid. There we discussed about the definition of the solubility, definition of the saturated solution, definition of the unsaturated solution. Okay. Today the solubility of a solid in liquid. So let me tell you one thing. Whenever solute combines with solvent, there is a formation of the solution. Okay. The solute and solvent gives rises to solution. And here we are telling that solubility of a solid in a liquid. The solute is solid and the solvent is liquid. As I said you in the last class, this is in the equilibrium, dynamic equilibrium condition will be there. So the solubility of solid in a liquid, here solute itself is a solid and solvent is a liquid. So when these two combine with each other, they gives rises to solution. Now we will discuss the effect of temperature, on solubility of solid in liquid. We are discussing about the effect of temperature on solubility of solid in liquid. Okay. So solute plus solvent, which gives this forward reaction, is dissolution, as you know, and this is a backward reaction which is crystallization, which gives solution. Here let us consider solute plus solvent undergoes the reaction and forms the solution. Consider the forward reaction, because solubility is the amount of the solute present in the specific amount of the solvent. So this forward reaction is solubility, that is dissolution. It will be the dissolution. Now if this dissolution is exothermic, if the dissolution is exothermic, as we are dissolving solute in a solvent, okay, the concentration will going to be increases. This process is called as dissolution, and this dissolution is exothermic. So what happens? Solute plus solvent, okay, when it is a dissolution process, as I am telling, the dissolution is exothermic here. Dissolution is exothermic. Exothermic means there is a release of heat. There is a release of heat. Suppose now I am going to increase the temperature. Now I am going to increase the temperature. Increase the temperature. So one principle I am going to tell you here, that is Le Chatelier's principle. Whenever there is a equilibrium state occurs, there is a changes like temperature, pressure or anything, the equilibrium will not going to accept it. What it makes? It wants to nullify the effect. Whenever the equilibrium state is occurred, during that time, if you are changing temperature, pressure or any other factors, the equilibrium does not accept it. It tries to nullify that effect, which already you know in your first PUC. So come to this point. Now the dissolution is exothermic and the heat is released. I am increasing the temperature. I am increasing the temperature that cannot be accepted by the equilibrium according to this principle. Okay, as temperature is increased, that cannot be accepted by the equilibrium. So what it makes? It makes the backward reaction. It transforms the solution content towards this reactant side. Whatever, for example, in the solution NaCl is there. Okay, as I am increasing the temperature, there is a formation of the ions like Na plus and Cl minus. As I am increasing the temperature, the equilibrium is not ready to accept it. So what it makes? It tries to send these ions towards the reactant side. It tries to send the ions towards the reactant side. But in the reactant side already ions are there. Okay, already these are soluble. Now where is the space for these ions to get soluble here? There is no more space. There is no more space here because already these ions are present. The reactant part side ions are present here. Whatever the ions are coming here, there is no space for the solubility. So we can conclude that when the dissolution is exothermic, okay, the solubility when the dissolution is exothermic, what happens? The solubility decreases. The solubility decreases with increasing temperature. With increase in the temperature. I hope so you are getting. See here, solute and solvent, this process which gives rises to solution, and this forward reaction is dissolution. And then now we are talking about when the dissolution is exothermic. It means solute plus solvent, here there is a formation of solution plus heat because it is a exothermic reaction. Heat is released. And now I am increasing the temperature. So as we are increasing the temperature, equilibrium is not ready to accept it. It tries to come towards the back side. It means backward reaction. It favors the backward reaction. But here towards the reactant side, there is no space for the solubility of these ions. That's why we can tell that the dissolution, whenever the dissolution is exothermic, the solubility decreases. Here, no space for the solubility of these ions. This solubility decreases with increase in the temperature. So we can say that the solubility decreases with increase in the temperature when the dissolution is exothermic. When the dissolution is exothermic. So let us go for the when the dissolution is endothermic. Suppose dissolution is endothermic. Okay. So again same thing, solute plus solvent dissolution solution. As I am telling, the dissolution is endothermic. So it absorbs the heat. It absorbs the heat because it is a endothermic reaction. So now solute plus solvent plus heat, as it is a endothermic reaction and dissolution process gives rises to the solution. Now, I will increase the temperature. Now, I am going to increase the temperature. So, when the temperature is increases, again it is according to the Le Chatelier's principle, the equilibrium does not accept it. Equilibrium does not accept it. What it makes? It will favors the more and more forward reaction. Whatever the solute and solvent dissolved, it favors the more forward reaction. As the more forward reaction occurs, there is a space. There is a space for the solubility of other solutes. There is a space for the solubility. There is a solubility. It means other ions can get soluble here. Because of the increase in the temperature, this equilibrium is not ready to accept it. It favors the forward reaction. So, the whatever the solute and solvent, they are in the forward reaction. So, here there is a space for the solubility of or other ions to get soluble here. So, we can say that dissolution, whenever the dissolution is endothermic, means when the dissolution is endothermic, the solubility increases. The solubility increases with increase in temperature. Are you getting? So, when the dissolution is endothermic, here there is a release of heat, then we are going to increase the temperature. So, more forward reaction occurs, there is a more space towards the reactant side. So, we can make other ions to get soluble here. That is why the solubility increases with increase in the temperature. Okay. I hope so you understand the concept. See here, the solubility of a solid in a liquid is affected by the temperature, effect of the temperature on the solubility of a solid in liquid. Suppose the dissolution process is exothermic, the solubility decreases with increase in the temperature. Suppose the dissolution process is endothermic, that time the solubility increases with increase in the temperature. I hope so you understand this concept. Next, we are going to discuss about the effect of pressure on the solubility of a solid in a liquid. Effect of pressure on solubility of solid in liquid. Okay. The pressure does not have more significant role on the solubility. There is no significant role of pressure. Why so? There is no significant role of the pressure on the solubility of a solid in a liquid. See here, why there is no effect of pressure? Suppose this is a solid and here we are dealing with the solid and liquid. As you know, the solid and liquid are highly incompressible. We cannot able to compress them. Okay, that's why the pressure does not have a significant role on the solubility of a solid in a liquid. So, the two things which are affecting on the solubility of a solid in a liquid, first one is temperature, second one is the pressure. How does the temperature? It depends upon the dissolution is exothermic or endothermic. Okay, and when we come to the pressure, pressure does not have any more significant role because of the solids and liquids are highly incompressible. Okay, so this is how we can explain the concept. I hope so all of you understood this concept. Okay, thank you.